Okay, let's move to part 2, GR, general relativity. Classical mechanics, in this case, okay, the space, the spatial coordinates, it will be in R3, three-dimensional extrinsic geometry. You see, all the derivations about the metric we can use for the intrinsic geometry, as you see later. See? That's why it's very important to understand in classical mechanics the three-dimensional extrinsic geometry. Okay, we are going to talk about the definition base vectors in curvilinear coordinate lines. See? General coordinate lines. See? You define the base vectors. This here we call covariant. And this one is contravariant. See? Now, you define them. Now, then you move to the differential of the position vector r. You see, the curvilinear coordinates are C1, C2, C3, because we are in three-dimensional space. Then we will define different elements: arc length element, surface area element, and volume element. From here, you're going to define the metric Gij, covariant, Gij, upper indices, contravariant. You see, when you see lower indices is covariant. On the other hand, for upper indices, you just is contravariant. You see, the base vector AI, you see I is the upper index. This is contravariant. This is the lower index. Okay? You see, these coordinates, they are contravariant. You see, because the indices are in the upper position. Now, after that, you see, we define arc length element, surface area element, volume element, and then we will see, I will derive in detail, step by step, properties of the metrics. Again, metric, it's very, very important for the general relativity. That's why I always write here general relativity, because our focus is the Einstein Field Equations. Okay? That's I would like to emphasize that. Don't, you see, you always put in your mind that, oh, we are in classical mechanics, R3, but in the Einstein studies, you see, the Einstein's researchers, he worked in the R4, but the metric, the properties, you can move the properties to the intrinsic geometry. Okay? And intrinsic geometry, there is no position vector. There is no position vector. You see? By the way, the intrinsic geometry can also be applied to classical mechanics. Okay? So, intrinsic geometry can be applied to R3 and R4 for dimension. See? but the extrinsic geometry only is applied to R3. It's clear what I'm saying? Okay. That's it. That will be part 2. Okay? And I'll derive this. This is an introduction, okay, or a message, doesn't matter. That's topics that you're gonna face, okay?